Record.
Hello, everyone. We are Rehab AI. We want to identify fixer-upper homes with computer vision. To introduce our team, we have Tony, myself, Yassine, Evan, Michael, Faisal, Alvaro. The objective of our project is to use computer vision to identify fixer-upper homes. Fixer-upper homes are typically sold at lower prices compared to newly built or renovated homes. This creates a great opportunity for equity growth or profit for home buyers and investors. Moving on to the app.
While they are really good deals, the problem is it's really hard to find them. Existing real estate markets do not have a filter or sort option to display only fixer-upper homes. Users must enter a zip code, manually browse through all listings, and then click on listings to just scroll through images to find a fixer-upper home. Our vision for this project is to use computer vision so that we can create a filter option to display only fixer-upper homes, or at least make them more visible. Here is our implementation over the course of this semester. We have two pipelines. Data scientists can use a Vertex AI pipeline to do all the data scraping, pre-processing, and model training in one step. And then developers can use our CI/CD pipeline to automatically change code, automatically build Docker containers, automatically test, and then automatically deploy our full stack application. I'm gonna hand it over to Evan to discuss more.
For our development, we utilize a GKE cluster for app scaling. We have two load balancer services for both the front end and the back end deployments. The front end containers make external API calls to Zillow to retrieve property information based on a zip code inputted by the visitor, which is then sent to the back end load balancer, which also distributes to the back end deployment for model inference. The back end containers pull images from Zillow and the latest WAND B model weights, and then classifies each property and then sends the results back to the front end containers, and the front end containers serve the results to the visitor. This dual load balancer architecture with the exposed backend IP was chosen specifically for a potential use case as an API endpoint for third-party developers to call in the future. Next, we'll talk about challenges of the project.
The first challenge is that our input training dataset is rather noisy. Here we show a few mislabeled input images from our web scraping results that consider fixer. From the very left, the image is considered a cluttered living room. It does not make a true fixer property. The middle image is an unrelated street view that is also not a good learning example. The right image is what considered as good example to train the model. Unfortunately, we have quite a few of these inconsistent labeling that polluted our dataset. To improve the accuracy, we attempted VGG16, two different versions of EfficientNet. None of them stood out, with VGG16 slightly better. Good quality dataset is crucial. We didn't realize how important it is until we saw it for ourselves. Second challenge.
The most challenging issue was the high latencies in performing our inferences. For example, the inference of 10 images initially took 32 seconds, which quickly translates into several minutes when loading several properties, each with 20, 30, and even more images. That brought us to develop two front ends competing for better results. Faisal.
Yeah, so to mitigate this issue, we implemented various solutions. So for example, we implemented redesigning our API calls to do streaming data instead of batch requests. We implemented distillations to create smaller models. We implemented with load balancers and more. And we also introduced some browser caching to reduce the load time down to 6.7 seconds for 10 images. Next slide. So through the culmination of our efforts, here's our working app. I'll pass it along to Tony.
Right. I'm super excited to show off our cool app that we developed. So very simple interface. We just put in a zip code to get started. Let's try 95122. Clicking search, we can see the search results loaded, several homes right here. On the bottom, this last one shows a fixer-upper label. So now we have a way to show very easily what a fixer-upper is. Let's try another zip code. Let's try 48211. So press search. So it's looking for properties. And then it found the properties. The message is saying that we're also fetching labels from the AI model. Oh, there we go. It finished loading, and now a fixer-upper label appeared here. So that looks fairly accurate right now. Yeah, and that's it. That's our MVP. Thank you again for an amazing semester. We're super excited to continue working on this and really enjoyed the class so far. Please let us know if you'd like any updates.